Okay? We're going to sketch this out. We want to start with the points. So we got to start with the F column on each of the charts. If I start with the first derivative chart, I see that I've got a y value here of 4 when x is negative 1. So I'll plot that point. I also see that I have a y value of 8 when x is 3. So we'll plot that point. In the second derivative chart, looks like we got 1 point to play with. We got a value of 6 right here in the F column. That goes with 1. So we'll plot 1, 6. And then, all right, now, where the function does not exist in both charts, we notice that it does not exist when x is negative 3. So that should be consistent from chart to chart. That can mean a couple of things, but for our purposes, probably the easiest thing to understand would be there's a vertical asymptote there at x equals negative 3. So I'll draw a vertical asymptote in. Between that asymptote and these points, that gives me a place to start. So now we focus in on the first derivative chart. We look to see about some direction now. If we look at the first interval, negative infinity to negative 3, we see that the first derivative is positive, so the function must be increasing there. We need to show a direction that is going upwards as everything comes up to where x is negative 3. So where x is negative 3 is the asymptote. Graph going upwards, well, we don't know where it's starting. Could start here. Just needs to have that trend going up. Could also start below the x-axis here and have that trend going up. Next interval, negative 3 to negative 1. So again, x is negative 3 at the vertical asymptote. X is negative 1 at this point. We see that the first derivative is negative, so the function is decreasing. That means we're going to have to show a downward trend from that asymptote to that point. Now, as you look at how the points kind of play out past that point where x is negative 1, looks like we've got an upward trend, right? We know the graph's going to have to go through these points and eventually get up to the point there where x is 3. And that matches up with this interval right here because the first derivative is positive. So it's increasing. And then past that point where x is 3, this interval of 3 to infinity, first derivative is negative, so graph will decrease. Where it decreases to, we don't know. We just need to show that downward trend. So we got our direction there, which means we got our graph for the most part. We just need to make sure the curvature is right. So that's where the second derivative comes in. For the second derivative, we see from negative infinity to negative 3, it's positive. So that means for the function, it's concave up. So we see from negative infinity to negative 3, the graph's going up. If it's going to be concave up, curvature would have to look something like this. And that would make sense. It would fit with that vertical asymptote there. For negative 3, the vertical asymptote to 1. So that's going to take me up to this point here where x is 1. We've got concavity that's going to be up as well because the second derivative is positive. To show that curvature, it's got to be down for this little interval, but concave up. So that would be down and concave up. And then from this point up to where x is 1, has to go up and be concave up. So that curve would fit. And then finally, from 1 to infinity, second derivative is negative, function's concave down. So from this point onward, got to follow the right direction, got to have a concave down curvature. So it's going to go up from this point to this point, be concave down. From this point on, it's going to go down and be concave down. So it might look something like that. Make sure you're hitting all your points. But I would say that curve we got there in purple That would be our function.